In this video, we're going to go ahead and cover an exciting integral that's going to require some familiar integrals that you might know. Now, I'm telling you, this integral has everything. It has manipulating the root, it has some substitution, some integration by parts, and then a familiar integral you're going to see at the end. So let's just take a look at this integral here. If you were to graph it, you will notice that it's pretty defined on the boundaries that we have, so there's nothing to worry about there. I don't know, it kind of looks like it exponentially goes up and then it just sort of starts converging towards the x-axis. It's kind of exciting, but anyway, the way we're going to go ahead and solve it is using the very first thing, which is going to be manipulating the root. So I'm going to go ahead and label this t. So we're going to say t is equal to the square root of 1 plus the natural log of x. Now we're going to square both sides so that we get t squared equals 1 plus the natural log of x. Okay, so far so good, because now we're going to go ahead and find our differential. So the derivative of t squared is 2t dt equals, and then over here we're going to have 1 over x dx. It's going to be a little interesting because what we have to do, actually, we could just move the x to the other side and get 2tx dt is equal to our differential dx. And this is perfect because that's exactly what we're going to need for the dx up here. Okay, so let's go ahead and start changing things. But before that, let's go ahead and change our boundaries, because right now they're from 1 to e to infinity, but that's in terms of x. We need to change them so that they're in terms of t. So let's see, when x is equal to 1 over e, then t is going to be the square root of 1 plus natural log of 1 over e. And think about what's going to happen here. 1 over e is basically e to the negative 1, and then this negative 1 can now come on the outside. So we have 1 minus natural log of e. Natural log of e is 1, so 1 minus 1, 0. Perfect. Okay, so we have our bottom parameter. And when t is equal to infinity, or when x approaches infinity really, then t is going to be the square root of 1 plus natural log. Now, I don't like to write it like this, but this is the way we should imagine it, that as natural log approaches infinity, that goes to infinity plus 1, it's still infinity. So we just say that t approaches infinity. So now we're going to have a very nice integral at the end. This will now become 0 to infinity, and then up here we basically just have t over x squared times, and then now let's go ahead and write our differential right here, which is going to be 2tx. All right, so let's talk about what's going to happen here. Well, the x on the top is going to cancel out with one of the x's on the bottom. All right, not too bad. And then the t's can multiply together. So this will give us an integral from 0 to infinity of 2t squared, and then we have over x with respect to t. We should probably have a dt right there. Okay, so this is a little odd. I mean, because I don't want to be dealing with, or we don't want to be dealing with the x anymore, because now everything is in terms of t. So let's go back to this x universe, which is over here. If we subtract the 1 to the other side, then we're going to get t squared minus 1 is equal to the natural log of x. And if we take the e to both sides, you can eat it. And now we have this right here, e to the t squared minus 1. Now, before I do any of that, let me just go ahead and rewrite this as e to the t squared times e to the negative 1. So that can better be visualized once we plug it in here. So now our integral is integral from 0 to infinity, 2t squared over, and then the x, we just said it was e to the t squared times e to the negative 1 dt. Okay, let's go ahead and bring this on the top, guys, and we're going to do one other thing. I'm going to rewrite this as 2t times t, and then I'm going to do e to the negative t squared and then e to the 1 dt. So what I did is I used properties of exponents to bring this to the top and bring that to the top, changing my exponents there. Well, let's see. We have a 2e. We have two constants, a 2 and an e. So let's go ahead and rewrite this and do 2e integral from 0 to infinity of t times t e to the negative t squared dt. Okay, now the reason why I did this is because what we want to do is we want to do integration by parts. So here's the way it's going to go. We're going to make our u value t, so our du will be dt. So this is our u value, so this entire thing will be our dv. So our dv is going to be t e to the negative t squared dt. And let's see, I'm going to try to do this in my head, but if I get this correctly, this is negative 1/2 e to the negative t squared. I'm just going to double check this and just take the derivative and see that is correct. And it looks like it is. Yeah, we are good to go. So now we're implementing integration by parts. So what we have to do is we need to have 2e on the outside. And then what we have is uv, so u times v. This is negative t over 2 e to the negative t squared, but you're integrating from 0 to infinity, minus, and then we have v du. Now v has a negative 1/2, so this will become plus, and I'm going to do 1/2 integral from 0 to infinity of e to the negative t squared dt. Do you guys recognize that particular integral? That's exactly what we're going to use up here. This is a Gaussian integral, something that comes up many times in, so many applications. Gaussian integrals are this is probably the GOAT of all integrals. I think it's essential that we know this value. Okay, let's go ahead and implement the first fundamental theorem of calculus here. When you plug in infinity, you're technically approaching negative infinity. I invite you to see why that's going to be 0 as it approaches infinity. So that's going to be done. And then when you plug in 0, you plug in 0 in here, that's going to go away. So this entire thing is just 0. So the last thing that I'm going to do is I'm going to distribute this 2e to this 1/2, and that's going to give me just e, integral from 0 to infinity of e to the negative t squared dt. And finally, this is the Gaussian integral, which is what we should know. This is square root of pi over 2. I made plenty of videos about this, but I can do it more, if you guys request it. But this will become square root of pi. Let's put an e in the front over 2. And we have successfully solved this integral using manipulating the root, then some simplification. We did u substitution at the end, and then we used the Gaussian integral to get e square root of pi over 2. Woo, that was fun. Anyway, that's going to do it for today. If you guys have any requests, please let me know in the comments. Please feel free to subscribe here to my YouTube channel. Follow me on Instagram or TikTok, and I'll see you in the next one.